Okay, good morning. Just a note, if you're not able to use the comment box, okay, which is a possibility if you're using Google, just send messages in Edmodo. If you have any concerns about what we're doing today. So today we're going to cover factoring, okay? This is probably one of the more important skills that you can use going through grade 11 and 12. We do piles and piles of factoring in the pre-calculus courses for 11 and 12. So basically what we did on Friday is we looked at the multiplication of polynomials. So we focused on binomial by binomial, but we did a binomial by a trinomial and such. So for example, if I went 3a plus 5, I would distribute it through, and I got 3a at 15. Okay, that was one of the first things that we did. Then we did the FOIL method, a plus 5 times a plus 3, in which we multiplied the first, so that's your first, so a squared, your outside plus 3a, your inside plus 5a, and then your last, so I've got outside, inside, and last, which was 15. Collect my like terms. Okay, so this is where our ending was. We had a squared plus 8a plus 15. Okay, now what I need to do, refer to it as division, because it is essentially dividing out, but we call it factoring instead because we're working with polynomial functions. All right, so what we're going to do next then is I'm going to look at a very basic example. So the very basic example is one of the first things that we do is use greatest common factor. Okay, so the greatest common factor. The greatest common factor is the largest number that divides evenly into two numbers. So for example, if I'm using 6 and 9, let's say, okay, what's the largest number that goes into 6 and 9? Well, 6 can't go into 9 evenly, but 3 can go into both of them. So the greatest common factor for 6 and 9 is 3. All right, if we did 6 and 12, the greatest common factor is 6. 6 divides evenly into 6 one time. 6 divides into 12 evenly twice. Okay, so it's pretty straightforward when I'm using numbers. Where we tend to have a little bit of difficulty is something like this. All right, what's the largest value that I can divide evenly into x and x squared? Well, if I multiply x squared out, it's x times x. And I can recognize that if I take x and I multiply it by another x, I'm going to get x squared. So realistically, the greatest common factor for both of these guys is x. X divides into x one time. X divides into x squared two times, okay, or x number of times. So if I have something like this, x squared and x to the fifth, all right, the greatest common factor that goes into both of them will be the variable with the smallest amount of the exponent, and that is x squared. Okay, so x squared goes into x squared evenly, and then x squared divided into x to the fifth would leave you with x cubed. Okay, because we subtract the exponents. So this is the very foundation of where we start with factoring, is we start with the greatest common factor. So I'm going to look at a little more complicated question in which we are doing prime factors. All right, so I have this. I need the greatest common factor for 6x squared and 12x. Now, you can do this one of two ways. The first way would to be break them all down into prime factors. Now, I'm not a huge fan because it takes time and there's a lot of work to it, but I will show you anyway. So the prime factors for 6 are 2 times 3 and then x times x. Oh, should be times there. Okay, so that's 6x squared broken down. 12x broken down is this. So when we're looking for the greatest common factor, we're looking for the value that each of these possesses. And if there's anything extra, it doesn't count. So for example, they both have 2 in it. They both have 3 in it. And they both have at least 1 x in it. So the greatest common factor for this would be 2 times 3 times x, which is 6x. So this is one very simple way, but a little more work, way in which we can take the greatest common factor out. Now, personally, I look at the whole numbers first, the coefficients, and I look at 6 and 12, and I say, okay, what's the greatest number that goes into 6 and goes into 12 evenly? So looking at it, I know that 6 goes into 12 evenly, and 6 obviously goes into 6 one time, so my greatest common factor for 6 and 12 is 6, which we did on the last board. And then the greatest common factor between x and x squared is x. X goes into both. Now I can't take x and divide it by x squared. So it's always going to be the variable with the smallest exponent in this case here. Okay. Let's look at one more example that's a little more complicated. Let's look at, so I'm on page 91 right now. I should have wrote that down earlier. Page 91. So I've got 18x y squared z, and then 24x squared y cubed z squared. All right. Okay, just 1 second. Need to fix this. It's over. Again, if you're following along live and you need me to slow down or you want me to explain something better, what I want you to do is you either add into the comments, but I know you may not be able to do the comments, or go on to Edmodo and do a private message on Edmodo and I can see it. Okay, so now looking at 18 and 24. Now, the one thing I do want to say before I get going any further, the one thing that you are going to have to improve, and it's a skill that gets lost somewhere along the way, is your multiplication table. Knowing what factors are is hugely important. For example, if I look at 18 and 24, 18 has these possible factors: 1, 2, 3, 6, 9, and 18. So doing that as quickly as possible is going to be very beneficial to you. Looking at 24, all my factors of 18 and 24. So I want to pick the one that is the largest in both. What is the largest number that goes into 18, divides into it evenly, and the largest one that goes into 24? And that is 6. Okay, now looking at the variables. So I've got x and x squared. So the largest one that goes into both of them evenly is x. Again, you take the one with the smallest exponent on it. Y squared and y cubed. Smallest exponent is squared. Z and z squared. smallest exponent is z. And there you have the greatest common factor. All right. Okay, so that takes us through till the end of 1, 2. Number 4 does the set of terms. Okay. So now I'm going to work my way into factoring binomials now. And I'm just going to follow along with the book for 1 second. So I'm going to look at question 6. So this is again page 91. So we had been looking at 2 terms and finding the greatest common factor. Now what we're going to do is we're going to take a binomial, and this is the first stage in factoring polynomial expressions. And I want to find out, okay, what is the largest value that can be divided out? That's what we call our greatest common factor. So I have 6x plus 30 here. So looking at this, what am I going to factor out? Well, what's the greatest common factor? Since there's only one x, it's not an option. But 6 divides evenly into 30. And so I'm going to factor it out or divide it out. And then I write down, what am I left with? So one way I look at it is I don't like to do this. Again, I'm just showing you different ways in which I would do this. So to find out what's left in the brackets, I divide by 6. Okay, so I get 6x divided by 6. Well, those cancel. That leaves me with x in here. And 30 divided by 6 leaves me with 5. So I factor out a 6 out of here. And I'm left with x plus 5. If I were to multiply it back through, I should end up with the same thing I started with. 6 times x, 6x. 6 times 5 is 30. Okay. Let's do one that's a little more complicated. (16r squared minus 12r). So working with the coefficients, that's the numbers in front of the variables. We call them coefficients. So 16 and 12, what's the largest number that goes into 16 and 12? Well, I know that 16 can't go into 12 and 12 can't go into 16. So that eliminates those 2 values. So the next largest in here, and I'm always looking for the largest to begin with. The next largest that goes into 16 is 8, but 8 doesn't divide evenly into 12. So then I continue to focus on 16. The next largest is 4. 4 goes into 16. 4 also goes into 12. So that's the value I'm going to take out. So I factor it out. So I'm going to put a 4 there. The greatest common factor between r squared and r, again, the smallest exponent is r. So what am I left with? When I divide 16r squared by 4r, 16 divided by 4 leaves me with 4. R squared divided by r leaves me with r. 12 divided by 4 leaves me with 3. Notice I have the subtract sign there. And r divided by r is 1, so I'm left with 4r subtract 3. Now this is the part that everybody tends to mess up. That is, when I take an r out of here, I have to realize that when an r divided by an r is 1, I mean, I get 1 times 3 is 3, so I don't write it in. But I have to remember that that r, when I divide it out, it exists as 1. Okay? So that becomes a little more important here. I'm going to do one here. I'm going to make this one up. Minus 4x squared subtract 4x, like that. Okay? So when I'm factoring out, I can also factor out a negative number. And generally, if the coefficient's in front of my variable is the large exponent and it's a negative, I'm going to take it out. Now, it's not necessary, but it will make your life easier as we begin factoring. So I'm going to take the negative 4 out. So I take a negative 4 out, and I take an x out because I have an x squared and an x. So I take that out of there. So now I have to figure out, okay, well, if I divide it out of each of these two terms, what am I left with? Well, -4 divided by -4 is 1. X squared divided by x leaves me with x. -4 divided by -4 is +1. X divided by x is also +1. So there's my factored solution. I take -4x. If I times it by x, I'm going to get -4x squared, which is that. -4x times 1 gives me -4x. So again, you can check your solutions on this if need be in order to see if you're getting it right. Okay. All right, so number 7 is stating the factor that's missing. Okay, that's essentially, they're going to give you this or they're going to give you this, and you have to find the other, is what's happening in number 7. Okay, so I'll look at 7b. So it's still page 91 and 7b. And on 7b, I have 4a squared minus 6a cubed. Now, it may help you to do this without looking at the second part of the solution on this with the blank, but it's up to you. Okay, so they're left with 2a subtract. All right, no, so sorry, 2 subtract 3a. And it wants you to find out what's in the blank. So basically what it's doing is it's asking me what the greatest common factor is. Now, if I didn't have this here, all right, let's say that this was missing. So clean up my mess here. So if this is missing right here, I'm saying to myself, okay, what's the greatest common factor that goes into 4 and 6? Greatest common factor that goes into a squared and a cubed, and I would put that in the blank. However, looking at this right now, this is what they say I'm left with. Well, what do I times 2 by to get 4a squared? Well, 2 times 2 gives me that, and I obviously need an a squared there. 2 times 2a squared is 4a squared. Minus 3a times 2a squared is minus 6a cubed. So I can work it backwards if necessary, but personally I would have just done this question without it and said, okay, what's the greatest common factor that goes into 4 and 6? It's 2. A squared into a cubed. A squared, it's always the lesser of them. And then I'm left with 2 minus 3a. So whichever way you're comfortable with. All right. Now, one of the things that just making sure we have no questions yet. One of the things that somehow makes things a little more difficult is if I'm actually going to factor out a term, okay? And by a term, I mean that there's going to be variables and an add or a subtract in it. So looking at page 91, question 8. Let's put that there, here, question 8. Okay, so I have the following. I have x minus 6, and 4 times x minus 6. So there's 2 terms right there. I've got x times x minus 6, and I've got 4 times x minus 6. And my question to you is, what's the greatest common factor between this term and this term? Okay, so all I'm saying to you then is, what does this term have and this term have? All right, that is exactly the same. And when I say that, you can't just say x because I have a couple x's and an x. It doesn't work like that. So what am I asking you? What is it that x times x minus 6 has and 4 times x minus 6 has? Well, the greatest common factor for this guy is x minus 6. It's whatever term is exactly the same in this one and in this one. So x minus 6 being the solution. Looking at the next one now. I have a plus 3 minus 7, a plus 3, I think is the, yeah. Okay, so what do both of them have? Well, they both have an a plus 3. All right? Okay, so the only thing exactly the same here and here is the a plus 3. And I keep them contained in the brackets. If they're exactly the same, then leave them like that. Now, the second part of factoring, which this question doesn't do, but I'm going to show you because number 9 does it, is, all right, if I take an x minus 6 away from here and here, what am I left with? Well, if I divide x minus 6 out, I'm left with x. If I divide an x minus 6 out, I'm left with 4. Okay, now those are going to be important values to us when we get into question 9. When I take an a plus 3 away from this term, I'm left with a. When I take an a plus 3 away from this term, I'm left with negative 7. Okay? So I am now working my way up into factoring binomials. So we'll look at page 91 now and question 9. All right, so here's what I have. S times S plus 5, subtract 2 times S plus 5. All right, the first thing I'm asking then, or you're to ask yourself, is what do both terms contain? What do both of those have? And you can see whatever they have, you put in brackets right here. So that's an S plus 5. Now the second set of brackets. Now this goes back to that distribution property that I showed you when we multiply in. And that is what's left. If I take an S plus 5 away, I'm left with S subtract 2. Now I have completely factored this expression right here, and I've got S plus 5 times S minus 2. Okay? So I'm going to do one more, and then I am going to show you how this and this are exactly the same by working back. All right, so the next one I'm going to do is this. So I've got G times G plus 6, add 9 times G plus 6. So the first bracket is whatever I have the same in both, which is G plus 6. And the second bracket is what is left over when I divide the G plus 6 out. So I take the G plus 6 out, what am I left with? G. Let me do this in a different color so we can. So what am I left with? This and this. So I write those down here. G, this sign right here, which is a plus, 6, and that's what I have right there. Oh, sorry, 9. My bad. 9. Okay? Now I want you to think about what we did with the distributive property. When I said, first of all, normally I FOIL these, Well, foiling these right now isn't going to show me how I get here. So what the distributive property does, well, what am I going to do? I'm going to take G times G plus 6. And then I'm taking 9 times G plus 6. And I end up with exactly the same as what I started with. Like that. Okay? So I am working my way down here to show you how to factor these questions. Okay? Now there's going to be an easier way to do a lot of this, but for right now we need to understand these steps. Okay? For example, we're going to look at 9b now. Here's what I have in 9b. In fact, I'm going to change this completely. I'm going to start, this is the first and most important thing that we're going to go through. I'm going to do all of it. I'm going to show you where our end game is here. So this is what I have right here. P squared plus 7p plus 12. Okay, so this somewhat follows number 9 on page 91. Okay, now here's how factoring works, and the reason that I said we need to focus on our multiplication table. So what we're looking at doing is this right here. I want to find the factors of that number. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Okay? Now again, I'm showing you the long way to do this that coincides with what we did in question 7 and 8. And then I'll show you, excuse me, I'll show you a much simpler way of doing this question. Now I want the factors of this last value, of my coefficient value, well, we call that a constant actually, not a coefficient, but a constant. I want the factors of 12 that add to give me my middle value, my sum, my 7. So of these factors right here, 1 and 12, 2 and 6, 3 and 4, I want to find the 2 of these factors that multiply to give me 12 and add to give me 7. Well, there's your solution right there, 3 and 4. So now I'm going to rewrite those in. Instead of writing 7p, I'm going to write 3p plus 4p plus 12. Okay? Again, this is going to be a longer version of what I think you should do with this, but it's a version that works fairly well. And when we get into more complicated values in which we have an a value in front of the p squared, it often helps to do this. So at this point, I'm going to draw 2 sets of brackets around my first 2 terms and my second 2 terms. Okay? So I've got p squared plus 3p. I want the greatest common factor between p squared and 3p. And I'm going to take it out. So I know that p goes into here, p goes into p squared, and p goes into 3p. That leaves me with p add 3. Okay? So p times p is p squared, p times 3 is 3p. Then I want to take out the greatest common factor between 4p and 12. That being a 4. That leaves me with p plus 3. Now, if I've done this correctly, this bracket and this bracket will give me exactly the same thing. Now, what's the greatest common factor between this whole term and this whole term? What do they both have? P plus 3. And what am I left with? p plus 4. So I started this whole question up here with p squared plus 7p plus 12. I found the factors of 12. I just write them out beside there. And I got to pick the two factors right here that add to give me my middle term. Because you can see that 3p plus 4p is 7p. So this is back to a binomial by a binomial. And if I were to FOIL it quickly, p times p, p squared. P times 4, 4p. 3 times p, 3p. 3 times 4 is 12. P squared plus 7p plus 12 is exactly what I started with. Okay? So this is what I call my factored form. And that's where we're shooting for. This is probably, when it comes to pre-calculus, one of the most important skills that we are going to learn because we use it over and over and over again. When we study quadratics in grade 11, applied in pre-calc, and then grade 12 we do trigonometry and logarithms with it as well. Okay, so I'm going to do one more that's in the book here. They make it a little bit easier for you because they put them into the two terms already. So I've got b squared minus 7b minus 3b minus 21. Okay? So the next step then is to put brackets like this. Notice my bracket right here contains the negative 3b subtract 21. I'll show you why in a second. So what's the greatest common factor between b squared and 7b? B. When I divide b squared out by b, I'm left with b. When I take negative 7b and I divide it by b, I'm left with negative 7. Again, check your work. B times b, b squared. B times negative 7, negative 7b. This one, make a star. Note it. I have a negative 3b right here. I gotta make sure I got this down right. All right, now I already don't like this question because I don't think it's gonna work out. I'll show you why. So there's a misprint in this book. Anyways, here's how this works. Negative 3b subtract 21. I'm going to divide a negative 3 out of here. This divided by negative 3 leaves me with b. This divided by negative 3 leaves me with plus 7. I can't go any further than that. Now I just contradicted myself because over here I said my brackets should be the same. Okay? Well, these brackets aren't the same because I have a subtract 7 and a plus 7. So if the question was written a little bit different in this particular book, it's not. If this was a plus right here, then this would work out to a negative 7. Now I have two brackets that are exactly the same. And I'd be left with that right there. So this question does not match up necessarily well with the one in the book because I wouldn't have had the same in the brackets here. So if I change it to a plus 21, then it works out a little bit better. Okay. So I think that pretty much summarizes everything that we need to be ready to do. Just going to look ahead now. So 5.3, I'm just going to show you a quick overhaul of 5.3. 5.3 is factoring trinomials. And We'll do that the next day, but I want to show you how it works one more time. So I have this here. This is the question that's given to me. All right. So I need to factor this. So what I'm going to do is I'm going to show you the quicker, more efficient way of doing this. When I don't have a value here, well, I have a value of 1 as my coefficient. I do this. I put 2 sets of brackets now. And what I learned over here is that if I take the first in the brackets using FOIL, b times b will always give me that first right there, b squared. So y squared, what are the factors of y squared? 1y times 1y. Y times y is y squared. It's that simple. It works that way every single time. Okay? Now, I need the factors of 12. So we just finished doing one similar to this. So 1 and 12, 2 and 6, 3 and 4. Okay? I need those factors that add to give me 8. So it's plus 2 plus 6. 2 times 6 is 12. Y times 6 is 6y. 2 times y is 2y. 6y and 2y add to give me 8y. So you can see this is actually a very simple, quick method on how to factor, provided my coefficient in front of the y squared is a 1. All right, so this is 5.3, and we'll be going through it again on Wednesday. So tomorrow, I'm just going to sit in here and answer any questions that you have for this. For the rest of the morning, I'm going to teach a couple things until about 11 o'clock. So I'm going to sign off on this one live, so you can watch this again after. If you have any more questions, send me an email, send me a private message in Edmodo. Okay, those are 2 ways in which you can ask questions, and at some point in the morning, probably from 11 o'clock to 11:30, I'll answer questions. So if you have a chance right now, go through 5.2 right now, start working on those questions, and if you have to ask anything about those questions, I'll probably be able to answer some more questions around 11 o'clock. Okay? That takes care of that. So I'm going to sign off. And if you have questions, like I said, email me or send me a message on Edmodo. All right. And I'll be back up in about 3 minutes with the grade 11 stuff.